we just talked about boiling point, and boiling point is when the atmospheric pressure equals to the vapor pressure, so what's being emitted from our liquid. Now, we also talked about that we don't need heat. We don't need a change of temperature for something to boil. So right now I have a beaker of water, just regular old room temperature water in this. I call this the Willy Wonka machine because it sounds like the little train in the Willy Wonka in the Chocolate Factory. But this is a vacuum. So what it is, it's increasing massive pressure inside here. And as you can start seeing, it starts bubbles a little bit on here. It's kind of like that simmer when you have water. And soon it's going to get into a roaring bubble. Now, there's no temperature change in here. I'm not putting any heat in here. So when I end this, it's going to still be room temperature inside here. So we'll let this see some little bubbles and stuff on here starting to form. All I'm doing is I'm changing the pressure. It's the same idea for a pressure cooker. Pressure cookers, no heat at all. What's happening is that the pressure in the pressure cooker is increasing, and that's causing whatever the food is to heat up. It's a different word, not the same heat energy we use in science. It's a different definition for that word. As you can see, we've got a lot of bubbles, and it's starting to bubble a little bit. Let's see a little bit more. I hope you guys can see those bubbles in there. Here, I can bring it closer. As you can see, we got some bubbles on there. Now, this machine does not work perfect, but as you can see, it starts bubbles right now. We're gonna call that boiling. This machine's very old, so the vacuum isn't as perfect. Oh, but we're getting a lot of boiling. It's kind of boiling right there. Alrighty, so now I'm going to remove, I'm going to turn off the vacuum. I'm going to release the pressure inside it. And when you guys are boiling water for like cooking ramen or mac and cheese, heating noodles, the pot's very hot. So probably you guys are very suspicious right now what's going on. There has to be heat, there has to be temperature. Well, you can't grab the pot, right, when it's pasta because, you're actually putting heat into it. Well, grabbing this, not burning. It's actually very cold. It's actually completely room temperature. Kind of a little bit cold. It's kind of cold in this classroom. So there you go. We were talking about vapor pressure, and we know that vapor pressure is the pressure when a liquid becomes into a gas, and what that gas is, when it collides off the walls, it's producing some pressure. So let's prove that pressure actually exists. So I have this water canister of sorts, has rocks in it for some reason. And I'm going to put some alcohol. It's ethyl alcohol here. No, it's not the alcohol we drink. This is different types of alcohol. And we are going to put that into the bottle. That should be perfect. Then I'm going to seal the top with some parafilm wax. This is pretty much wax. It's easily mendable to cover up any areas to prevent any air to get into. I'm going to just agitate it, and what I'm doing right now is I'm increasing the liquid to become a gas. I'm waiting for it to vaporize. You start seeing the bulge on top. Already you can see some kind of pressure, some kind of gas forming. Sorry guys, that's my phone. Alrighty, we get it. Nice. And I also want you guys to observe how much liquid we have right now, and we're going to compare that with what we're going to have later as well. Alrighty. Let me go ahead and get some tongs, turn off the lights. switches. Should be right here. Alrighty. Now, let's watch the magic happen. There we go. Alrighty, so let's let that cool down a little bit. So what just happened was I lit the gas, and obviously the fire happened. And if you notice on the bottom, we have a lot more liquid than what we started with. Because remember when we talked about types of reactions? This was a combustion reaction. The alcohol was our organic compound. It reacted with the air, the O2 in the air, and it produced that carbon dioxide, that gas, and the smoke, and a little bit of water in here. So it's obviously it's not pure water. I can't drink this, but we have a lot more liquid than what we started with. Alrighty, thanks guys.